So let's do a problem now on Avogadro's law, a little bit different kind. This is calculate the volume occupied by 4.11 kilograms of methane at STP. Okay, so according to Avogadro's law, we have to convert this to moles. Okay, so convert kilograms to moles, which means that we start with 4.11 kilogram. Now remember, we have to convert the kilograms into grams first. So that's our first conversion. In 1 kilogram, there's 1,000 grams. And then we have to convert the grams to moles. So moles, grams. In 1 mole of methane, there are 16.04 grams of methane, just from the periodic table. And now, since this says that this is at STP, we can go ahead and use the molar volume, because in 1 mole of gas, there are 22.4 liters of gas. Okay, so keep it simple. And then the answer for all of this calculation is 5.74 times 10 to the power of 3 liters. Okay, so that's the final answer. Again, keep it simple. All you need to do is moles, and once you have the moles of that at STP, the molar volume is 22.4 liters, okay, of gas. All right, now what we're going to do is go on to combined gas law, okay, and start doing some problems here. So the question is, a sealed can with an internal pressure of 721 torr at 25 degrees centigrade is thrown into an incinerator operating at 755 degrees Celsius. What will be the pressure inside the can? You might hear me saying Celsius or centigrade. It doesn't really matter. Both of them are the same things. Anyhow, here's how we set up problem up. So the internal pressure, which means P1, is equal to 721 torr, and the T1 is 25 degrees Celsius. Okay, it's thrown into an incinerator operating at 755 degrees Celsius, which means that the temperature, the new temperature, is 755 degrees Celsius, and we're asked for the pressure at that temperature. Okay, and so the first thing we do before we even start doing anything is convert our centigrade into Kelvin. And so 25 plus 273 is 298 Kelvin, and then 755 plus 273 is 1028 Kelvin, 1028 Kelvin. Now we don't have any direct relationship between pressure and temperature. Okay, pressure and volume have a relationship, temperature and volume have a relationship, but not pressure and temperature. So we go ahead and write out the combined gas law, which is P1 V1 over N1 T1 is equal to P2 V2 over N2 T2, and then we cross out whatever we don't need. Okay, so for example, the number of moles are constant in this case, and since we're dealing with a sealed can, then the volume is also constant. Okay, so which means that our equation that we need is P1 over T1 is equal to P2 over T2. Okay, so that's the equation, and what we are calculating now is for P2. Okay, and so again with cross multiplication set up, we have P2 is equal to P1 T2 over T1. Okay, and so then P1 is 721 torr times T2 is the second temperature, which is 1028 Kelvin, and then the initial temperature is 298 Kelvin. And once you do all of this wonderful calculation, your answer should come out to be 2487 torr, which if you want, you can bring it down to exponents as 2.49, or actually, sorry, 3.5 times 10 to the power of 3 torr. Okay, because our smallest significant figures was 25, which is 2 sig figs. Okay, so that is one setup. Now again, when you do these problems, you should look for what you need from the combined gas law. Okay, and then deal with the problem. The next problem is, if a fixed amount of gas occupies 253 2.53 meter cubed. So I'm going to go ahead and start writing my numbers as I'm reading the problem, so it becomes easier for me to handle all of this. So if a fixed amount of gas occupies a volume of 2.53 meter cubed at a temperature, initial temperature of minus 15 degrees Celsius, and at 191 torr, which means my initial pressure is 191 torr, what volume will it occupy at temperature of 25 degrees Celsius and a new pressure of 1142 torr? Okay, so now when I do this, I have all my data ready to work, all my P1s, V1s already written out, and all I need to do is make sure that I convert everything into the right units. So especially for temperature, the pressure, so long they're in the right units, it's fine, they should be in the same units, but for temperature you definitely have to convert those. So plus 273 for both, and so the temperature for the first one is 258 Kelvin, and this is 298 Kelvin. Okay, and so then again we write our gas law, which is P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. Now it says a fixed amount of gas, which means that we don't need the moles, okay, over here. And we're also calculating for the second volume, which means we're calculating for V2. Okay, so which means V2 is equal to P1 V1 times T2 divided by T1 and then P2. And the only reason I wrote my T1 under T2 is because of the units. Okay, that way I keep a track of everything. All right, so that is our V2, which means now I can go ahead and plug in all the numbers. So pressure 1 is 191 torr. Volume 1 is 2.53 meter cubed. You can see I didn't change my volume here. I could change it to liters, but it doesn't really matter. Okay, in this case, temperature is the most important thing. And the second temperature here is 298 Kelvin, all divided by P2. The second pressure is 1142 torr, and the volume is what we're trying to figure out. And then T1 is 258 Kelvin. Okay, Kelvin, torr gone, we'll be left with meter cube. Okay, so then our final answer for this one is 0.4887, which is in two significant figures, that would be 0.49 meter cubed. Okay, again, not liters, this one is meter cubed. So that's our final answer for this problem.